with our review notes on measurements and calculations day 1. You should, based on that half sheet that we just did, you should be able to tell me what the most important parts of that was, of this video. And dealing with, okay, those most important parts, you should be able to define element. Okay? You should be able to define what is an element. You should be able to list the 5 main branches of chemistry. And finally, you should be able to distinguish between a qualitative and a quantitative observation. So what was an element? What was an element? An element is a pure substance that cannot be decomposed by ordinary means into other substances. Up here in the front of the room, we have a periodic table of elements. I gave you a periodic table of elements, okay? So, by ordinary means, an element cannot be decomposed into other substances. Here's an element of sodium right here. Okay, sodium is a metal. What you might not believe about sodium is that sodium's really, really soft. And if you would have a chunk of sodium, you could cut that with a knife. Okay? It's something similar in its softness to butter. If you pour butter out of the refrigerator. Now, the thing about sodium is it is very, very reactive. It's what we call an alkali metal. Okay? If you have sodium and it is in the air, it will immediately react with the air. So we hardly ever find sodium by itself. It is so reactive. There's another couple of elements. The first one here on the left, this guy right here, I'm sure you've dealt with that before. That is aluminum. Okay? I'm sure you've had a soda that was in an aluminum can. You probably at one time or another used some aluminum foil, right? So we're familiar with aluminum. The second one here is bromine. Okay? Is bromine. So you would find all of these on the periodic table. Sodium. Here's aluminum. Where's bromine? Right there is bromine. All right? So all 3 of those are on our periodic table of elements. Branches of chemistry. Okay? Let's talk about the 5 branches that you should know. Number 1, organic chemistry. Organic chemistry is dealing with substances or matter that contain carbon. Okay? So you're going to see chemistry is the study of matter. Organic chemistry is going to be the study of matter that contain carbon. Well, let me ask you this. Either you contain carbon or you don't contain carbon, right? Well, that's what inorganic is now. Okay? Organic contains carbon, so what do you think about inorganic? The study of matter that does not contain carbon. All right? So when we talk about inorganic and these things right here that you're going to see, those we'll talk about in the next month or so. Those are different energy levels that have the probability of electrons. Okay, those are electron shells and orbitals that we'll discuss later on, probably in the next month or so, when we talk about electron configurations. Biochemistry. Well, what is bio? Life. So this is the chemistry of life. Okay? So biochemistry is really the study of chemistry in living things. Now, you've all taken biology. That's a prereq to get into chemistry. Do you ever remember seeing anything like this guy right here. This is a chloroplast. Well, what happens at the chloroplast? Photosynthesis, right? You've heard of photosynthesis. This is biochemistry because look at this. Here is light, here is water, here is carbon dioxide that are reacting in a chemical reaction, and it's producing oxygen and glucose, which is a sugar. Photosynthesis is a biochemical reaction, a chemical reaction that's happening in a living thing. Okay? We don't undergo photosynthesis, but we do have reactions going on in our body. Probably the one you talked about in biology would be cellular respiration, okay, which is the reverse reaction of that photosynthesis. Physical chemistry. Physical chemistry is the fourth one. Physical chemistry is the physics of chemistry, forces and matter. If you look at this diagram here, okay, here is the atomic structure where we have a nucleus with protons and neutrons, and here are electrons orbiting that nucleus. Now, are there forces that are occurring between positive and negative charges? Absolutely. So this would be an example of those forces of matter, okay, those forces, and it's the forces of opposites attracting. The fifth and final branch of chemistry is analytical chemistry. Okay, analytical chemistry, and this is dealing with the study of high precision measurements. If you look at this lady here, she is using a pipette there. That is a micropipette. So she could be actually measuring a microliter of something, okay? Which we talked before, we're familiar with milliliters, but we don't go any below milliliters, or we haven't probably. Well, we're going to talk about microliters in here, in which we get even smaller amounts of measurements, and that particular micropipette that she's holding right here is something that hopefully we'll get to use. I don't know if we'll use it a whole lot, but we'll use micropipettes every once in a while. Okay. And the last thing, and we're going to get a bell here, so we'll probably pause this and come back and do the remainder of this afterwards. But types of measurements and observations. Okay? Types of measurements and observations. We discussed a qualitative observation. Okay? That is more of using our senses to make observations. Okay? Seeing some physical change in state. Looking at a color. Okay? I look outside right now and I see water standing in the parking lot. So my observation is, oh, must have rained. Okay? Must have rained. I can see water out there. Okay? Look at this guy here. He's cold. He's shivering. Okay? That's a physical observation that I can make. Oh, that guy is cold. Now, how does that deal with a qualitative compared to a quantitative? Well, a quantitative measurement will involve numbers. Okay? It deals with quantities. So, I look outside and I say we got a half an inch of rain, 0.5 inches of rain. That is a quantitative measurement. I'm telling you how much it rained. I look here and I say, whoa, it's cold out. It's 20 degrees Celsius. Okay? It's cold out, but I'm giving you an exact number. So we were talking about these quantitative analysis, okay, compared to qualitative. And I use the example of the rain, okay? A qualitative analysis would just be, hey, look outside, it's wet, it must have rained. A quantitative analysis would be, we got half an inch of rain, okay? Same thing with the guy that's cold, okay? The guy that's cold. If I say it's cold out, is my cold the same as your cold? Okay? Probably not. Probably not. I don't mind it cold. Okay? So my cold might be 0. Okay? Okay, might be 0, might be 32 degrees Fahrenheit. Anything below freezing might be cold for me. Now, my mom would tell you that if it's below 50 degrees, she's got to put a sweater on because it's cold. Okay? But that's not the case for me. So our colds could be something different. But is 32 degrees Fahrenheit the same for my mom and myself? Yeah, that's a quantitative. It has a number involved. Okay? Now, the final slide here that we're going to go over is just dealing with these, the different types. Here is some qualitative. Here is some qualitative data. Colors. Smells. Okay? Names. Okay? But we all know some specific. I just smelled it today at lunch. I said, man, that smells like somebody's making popcorn. Okay? Quantitative. Shoe size. 10 and a half. Okay? Weight of a person or subject. Or scores. Okay? So, once again, what should we be able to do? We should be able to define what an element is. You should be able to tell me the 5 branches of chemistry. And finally, you should be able to tell me the difference between a qualitative and a quantitative observation. Okay? Those were the goals of the video notes, measurements, and calculations, day 1.